This is lesson 2.6 from your textbook. I'm going to go over the notes with you, and then your assignment is from the book. So before we can do anything, we need to review some of the properties. So hopefully you've seen these, so I'll go kind of quickly through. But it's a video, so if I'm going too fast, you can always pause it. The first one is the commutative property of addition. So that's typed out for you, and then you can put this definition in the definition category, and then I'll talk about it down here with the examples and hints. So the commutative property says that you can change the order when you're adding. So an example, 7 plus 3 is the same thing as 3 plus 7. So you have the commutative property of addition that changes the order when you're adding. And then the commutative property of multiplication changes the order when you are multiplying. So you could say the quantity of 6 times 4 is the same thing as 4 times 6. So when you're adding or multiplying, you can change the order based on the commutative property. The associative property says you can change the groups. Okay. So if you think about who you associate with people that go to Aquinas, you associate with the people that go to your church, you associate with the people that play your same sport. So what groups of people are you with? So we're changing the groups. So I can change the groups when I'm adding. So I can have 7 plus the quantity 3 plus 2 is the same thing as adding 7 plus 3 first and then adding 2. Both add up to 12, so they're the same. You can change the groups when you're multiplying, and you change the groups when you're adding, and you can change the groups when you are multiplying. So we have 3 times the quantity 4 times 2 is the same thing as 3 times 4 times 2. Both equal 24. Now notice everything is still, the order is still the same, 3, 4, 2, 3, 4, 2. I haven't changed the order like the commutative property, I've changed the groups. In this parentheses I have a 4 and a 2, and in this parentheses I have a 3 and 4. That's indicating that I have changed the grouping, not the order. Okay, the additive inverse says that you can add the opposite to something and get 0. So I can do 7x plus negative 7x, and that will equal 0. Now with multiplying, you can't add the opposite, so with multiplying, the multiplicative inverse is multiplying by the reciprocal. And with the multiplicative inverse, when you multiply by the reciprocal, you get 1. So you take 2/3 times 3/2, you will get 1. So multiplying by the reciprocal gives you 1. That's the multiplicative inverse. The additive identity says what can you add to something to not change the value? Well, when you're adding, you can add 0 and it doesn't change the value. So I can take 14y and add 0, and it's still 14y. It doesn't change the value by adding 0. Now if you multiply by 0, that's going to change the value. So the multiplicative identity is not multiplying by 0, but multiplying by 1. So the multiplicative identity says, that you have 4x and you multiply it by 1, you're still going to have 4x. Multiplicative identity. The distributive property, you see this all the time, but if it says you take a times the quantity of b plus c, you can rewrite it as ab plus ac. So for example, if we have 3 times the quantity x plus 2, you can rewrite this as 3x plus 3 times 2, or 3x plus 6. Okay? Now I know that most of us are not going to write it this way, but it's going to come up a little bit in your homework tonight, so I want you to recognize it. They're just doing the distributive property. The reflexive property. The reflexive property says that a number equals itself. And this seems kind of silly right now, but we're going to use this a lot when we do geometric proofs. Whoa, hold on. There we go. Later on. So we could say that 9g equals 9g. The symmetric property. There's two properties that are an if-then statement, and the symmetric property is one of them. It says if A equals B, then B equals A. We're going to use this today, but we're also going to use it more in the geometric proofs. So we can say if x equals 2, then 2 equals x. And the last property is the transitive property. And the transitive property involves three things. And you may have learned previously about the chain rule. This is kind of an example of that. So we could say if x equals 2 and 2 equals y, well, then we know that x and y have to be equal, right? That's the transitive property. But the symmetric property involves two things, and it's an if-then statement. The transitive property involves three. Okay, so I'm going to show you some properties. You do not need to write any of this down. Just kind of listen around, listen to me, and figure out what the properties are. Oh, whoops, I tried a couple. Got ahead of myself. The addition property of equality. It says that if A is the same as B, that you can add the same thing to both sides of the equation. You use this when you're solving an equation. So if you have 3x minus 7 equals 4. To solve this, you can add both 7 to both sides so that it's equal. So we get 3x equals 11. Now, when we do these in our proofs later on, this line will not be written. We're just going to go from step 1 to step 3. Okay? But that's the addition property of equality. The subtraction property of equality is the exact same thing, except now you're subtracting the same thing for both sides. So an example, if I have 5x plus 3 equals 10, I can rewrite this as 5x. This is kind of my if, and this is my then. I can rewrite this as 5x equals 7 because I subtracted 3 to both sides of my equation, and it was equal. I can do the multiplication property as well. A equals B, then you can multiply both sides by C, and it'll work. So what if I have the equation 1/3 x equals 5? Well, I can solve that by multiplying both sides of the equation by 3, so I get x equals 15. So if this is true, then this is true, and I was able to get from line 1 to line 2 by using the multiplication property of equality. Last but not least is the division property of equality. And this division property of equality, it's the exact same as we've done before, except C can't be 0, so we can't divide by 0. So if we have 3x equals 21, we can say x equals 7, because we divided both sides by 3. Now I'm going to show you some examples. You just follow along and listen. You don't need to write anything down. Just reviewing the properties that we just talked about. Okay, so what properties are these? So if we look at number 1, well, most people can see that on the right they've taken that and distributed it and get the left. So this is the distributive property. Okay. Number 2, they've added the opposite and got 0. When you add the opposite and get 0, that is the additive inverse. Okay, number 3. On the left it says 7a plus 9. On the right is 9 plus 7a. So they haven't changed anything except they've changed the order in which they've written them. So when you change the order, that is the commutative property. So we can say commutative of, and they're adding, is commutative addition. Okay, number 4 is an if-then statement. We only have 2 properties that are an if-then. So that's really the symmetric and the transitive. So if g equals 4, then 4 equals g. And you can write it on the other side of the equal sign. So this is the symmetric property. Okay, number 5, they're multiplying by the reciprocal. So that is the multiplicative inverse. Number 6. And number 6, everyone says, oh, that's a distributive property. The distributive property only has parentheses on one side. So then you say, oh, well, it must be the associative property because it has parentheses. They're grouping. Well, let's look at these parentheses. Here it says 2x minus 7, and here it's 2x minus 7. The associative property changes the groups, but here the groups clearly have not been changed. What's been changed is where the 4 is. First it's in the beginning, then it's in the end. So if we change the order, it's the commutative property. And since this 4 is right next to the parentheses, that means multiply. So it's a commutative property of multiplication. Now compare number 6 to number 7. In number 7, the parentheses are different. So if the parentheses are different, one has 3x, one has 4 times 3, we've changed the groups. But notice the order, 4, 3x, 4, 3x, is the same. So when you change the groups but not the order, that's the associative property of multiplication. Last but not least, we have an if-then statement, but this involves 3 things, h, 2, and k. So when it's involved 3 things like that, that is the transitive property. Okay. So you're now going to go to the next video, which is on proof notes, which is the second page of this packet that you have stapled together.